Okay, thanks everyone. Sorry about the false start. So as I said, the talk's going to be all about how we can safely evolve APIs and how we can manage that kind of contract or promise that exists between API providers and consumers. Hopefully my Mac works now. Yeah, so I'll skip this slide. It's just about me. I'll fill you in tomorrow. So what I'm going to look at, just to set the scene a little bit, is just kind of give you, because you mightn't be working so much in the API industry, just kind of what's happening at a macro level across the API landscape, how we think about designing for the future of APIs and what that means from an extensibility purpose. And I guess the too long didn't read summary is that we can't just rely on solid extensibility practices if we really want to make sure that we can have long-living relationships between providers and consumers. And what I'll be kind of filling you in as a proposed solution is the concept of bidirectional contract testing. So this is an approach really to try to calm the storm that's out there with the proliferation of APIs that we're seeing. I'll give a very, very quick kind of static demo on it and then leave you with some takeaways. And I'm happy to talk a little bit more later in depth, but I won't keep you here any longer than we need to. So microservices and APIs in general are exploding across the general enterprise landscape. And I think across any type of industry that wants any digitalization aspirations or has digitalization aspirations, it's APIs that are effectively the means for having those software components communicating with each other. The graph on the left-hand side is from our State of Software Quality Report for APIs last year. So we surveyed over 2,000 practitioners across 18 industry verticals to get some feedback as to kind of what they're seeing in their jobs. And on the right-hand side, it's from Postman's State of API report last year. And I think you can basically really see that microservices are one of the drivers for this proliferation of API generation. And of course, we now have Gen AI and AI capabilities on top of that since these reports were crafted. Microservices are also more than a fad. So they've gone up that slope of enlightenment, down the other side, and they're here to stay for a number of reasons, but one of them is because it really does promote the ability for us to have reusability within organizations, allowing us to build smaller software applications and hopefully benefit from reuse if we can communicate the availability of those services in a way that's easy to discover. Now, the problem is that we're producing APIs at such a rate that actually staying in control of our API landscape in any atypical enterprise that's out there, be it healthcare, travel, financial services, whatever the case may be, they are struggling to keep in control of the number of APIs that they have. And Gartner, the industry analyst, which you may or may not be aware of, their reports are also telling us that by next year, less than 50% of APIs produced in production by medium to large organizations will actually not be managed. So they won't be under any kind of strict control from an enterprise perspective. And this causes lots of problems, as you can imagine, for whomever is responsible for these, be it from a security perspective, be it from spinning the wheels and not getting any reuse across the tens or hundreds of teams that may exist. And it also really restrains and constrains teams with regards to having a good knowledge graph as to what APIs they have, who's consuming the APIs, and what is the usage thereof. And this blindness is causing lots of challenges and lots of cognitive load to be managed kind of in memory by the teams themselves. And then if you have that star developer who leaves on to the next job, all of that knowledge has walked out of the building with you as well. So the blindness, of course, causes many, many challenges. And the one I'm going to kind of focus on for the next 20 minutes or so is that it actually is going to make our jobs for evolving that API into the future much more difficult. Now, that's not to say that we shouldn't try to design for extensibility. We absolutely should bake solid design practices into how we bring APIs to production. I'm definitely an advocate for a design-first approach. So thinking about the problem that you're trying to solve, modeling that out, designing the API, and really putting the consumer of the API first and foremost. So what I say is, if we're designing an API to be consumed any way outside of our team, we should be putting ourselves in the seat of the consumer. And what that often means is that it's actually going to be harder for us to deliver the API in a way that makes it easy to consume, but that's what we should do. We should always prioritize the needs of the consumer rather than what's easy for us to do from a provider perspective. And I think that goes right back to the opening talk this morning around you need to provide capabilities that are easy to use for the end users that are going to be using them. And of course, if we do that well, then we get one of the success properties of a successful API, and that's longevity. So I think that's one of the things that we should be striving for. So that's like a little bit abstract as to how we can design for extensibility, a little bit more on the tactical side. Of course, if we can treat the APIs as being a contract or a product that we're making available to the consumer, it means that we have a much more focused perspective on some of the properties and qualities when it comes to usability of an API. So we should follow simple kind of tactics like defining our extension points. So if you think you're launching an initial version of an API or maybe version 2 iteration of an API, you should continuously communicate to the consumers to say, this part of the API over here, it's pretty stable. We're not expecting any changes there. This is a brand new endpoint that we're bringing out. It may be a little bit more volatile, so do expect to see some extensions in this part of the API over time. Don't be afraid to communicate that frequently with your consumers. Also communicate how consumers should deal with extensibility. So make your extensibility pattern available to them. So I think must ignore is probably one of the most common ones that I see out there. So what you're informing your clients is if you encounter something in the API that you don't understand, then you must ignore it. You know, make sure your implementation does not break, and we make a promise to you as a provider that that will be backwards compatible and it won't meaningfully impact the functionality that was there before we extended the API with that new property or that new object. Have a decent extensibility, a decent versioning strategy. So semantic versioning, for example, is one that's pretty common in the space that I operate in. And when it goes back a little bit to about communicating the extensibility patterns, I think Postel's law is something that we also see very, very frequently. And that goes back to the must ignore on the client side, but you want to be tolerant from a server perspective. So if you receive something that is sufficiently correct, you should accept it. So I think the saying goes, be incredibly broad in what you accept, but be as specific as you can with regards to what you return back to the clients. If you can test for extensibility, I think that's very, very good. So if you can provide mock endpoints or virtualized endpoints that allow clients who might be on an older version to peek ahead and see if their client is still compatible with the latest version, that gives them much more confidence to move along with you. And ultimately, you want to use that communication point to kind of big up that your API is evolving and clients can benefit from it when they, if they move along with you. So anytime you add something, communicate it through a changelog, sell the value of that API to your consumers again. I won't go through the don'ts because I know we're kind of short on time, but these are, you know, very run-of-the-mill don'ts. You know, don't add required inputs to an interface that you've already exposed. Don't remove outputs or make them optional. Unless you know it's safe to do so, of course. Don't change the type of a property, or don't introduce a new property which in turn or infers a change to the initial meaning of an existing property. When it comes to Booleans, use them as sparingly as possible if you want something that is extendable into the future. So, you know, if we do this, will we be successful with regards to an enterprise API that we're exposing out to lots of providers? Well, no. Probably not, unfortunately. So extensibility on its own is not enough. And actually, the API industry is really struggling when it comes to the design expertise that are there. So I think lots of companies are really, really struggling to have good API designers that understand that this will probably be the longest living piece of software that's created. The technical stack underneath that interface may change, and a consumer should never be hindered by that. If you can protect that promise that you're making through that interface to your consumers, it actually gives you incredible freedom from a technical debt management perspective on the provider side. So the pitfalls that remain, even if we are doing well from an extensibility perspective, is that we still have major version proliferation. And this is kind of something that's coined well by Hiram's law. And Hiram's law states, if I can recall it, it is with a sufficient number of users of your API, it doesn't matter what you promise in the contract definition that you expose, all observable behavior of that API will be depended on by somebody. So whether or not you've explicitly said that it behaves in a particular way, someone will depend on it behaving in that way. And then if you change that unwritten rule, you unlikely or more than likely will have someone complaining to you. And this really causes, at an enterprise grade level, it causes a knee-jerk reaction where teams who have lost that visibility on who's consuming their API, it makes them very fearful of introducing change. So what do? Well, they create a V2. Because then they know that they're not going to break anyone consuming V1, and that's all well and good, but that incurs lots of actual challenges for an organization, and cost is probably the main one. So it's not cheap to maintain multiple versions of similar but yet different APIs. And there's similar real costs then also associated with testing. So if we've, trying to bring over our testing approach from a more monolithic architecture over to a microservices approach, it's going to be difficult for us to actually realize the return on investment that we're proclaiming will happen if we magically move to a microservices architecture. And just to kind of describe it, this is a very, very simple overview of an application. So let's assume that if I wanted to apply an end-to-end testing approach to validate whether or not it's safe for me to make changes to the consumer, well, really what I would have to do is spin up the whole environment stack for us to be able to make sure that we could safely evolve that consumer, and that's quite expensive. So we see that we've lots of different microservices that are underneath the hood. We have to manage the data, we have to potentially manage an API gateway, and we have to do this every single time we're making a change to the consumer just to prove that the system as a whole is still working. So if we think about, applying that traditional testing pyramid that we might have been using in monolithic software over to the microservices world, well, it doesn't really fit. It's not fit for purpose per se. It's expensive, number one. It's slow for us to get feedback, and what we want to do is we want to get feedback as fast as possible in the delivery cycle. If you encounter a bug in the design or in the development, it's very, very cheap to fix. If you find it only when it's in production, then of course it's more expensive. These things at an enterprise level, which may or may not surprise you, are incredibly brittle, so they're unreliable. I think we've all been there, or maybe not, depending on how many people have worked here in enterprise settings. But you will have a test team responsible for these end-to-end suites. There might be 1,000 tests in there. They will run them. 2 will go red. They will say, I wasn't expecting that. Let's just run it again to make sure they're red. And then they're green, and they're like, okay, they're green. We have enough to move on to the next environment. And they actually don't go to the trouble of determining why those 2 particular tests went red. And they're also not targeted. So imagine in the previous slide that I had up, if I was changing the consumer who's north of the gateway, if I have to spin up a full end-to-end test, something might fail that's actually related to a downstream microservice, not relevant to the change that we're being made, but still we're exercising the assertability of this change using end-to-end testing. So of course, this brings up also how do we manage the dependencies between all of these things from a testing perspective. And this is a very simplified view. So 2 continuous integration pipelines. So GitHub Actions, Jenkins, Azure DevOps, Circle CI, whatever you use for these things. So I have one for a consumer, and I have one for a provider across 3 environments. So a very, very simple setup, just to kind of walk through an example. So you could imagine that if I wanted to evolve the consumer v3, what I would likely do is I would want to run tests between the consumer and the provider that it depends upon, make sure that those 2 software components can work together. And if maybe other tests pass as well, which are maybe more non-functional related, like security, performance, etc., then you would say I have enough to be able to move to the upstream environment. But of course, the fact with microservices and componentization in general is that we want to be able to evolve and promote individual software packages towards production without having to move the providers and consumers in lockstep through our environment architecture. So what if I wanted to move the consumer v3 to staging on its own without deploying the provider? Well, of course, I'd have to make sure that the consumer on the CI environment is also compatible with the provider that's on the upstream environment that I'm about to move to. And similarly, if I wanted to move consumer v2 from staging to production, I would have to make sure that it's, first of all, compatible with the provider v2 that's on the staging environment, but then it's also still compatible with the provider v1 that's on production. So in this very simplified example, you begin to see how things can get complex a little bit quicker than you may expect in a microservices architecture. And again, vice versa. If I wanted to move the provider without having to move the consumer, we start getting this bigger matrix of actual compatibility checks that we need to be able to do on the fly. And I'm going to propose a solution to this, of course, which is bidirectional contract testing. But before I do that, I'll just put a quote on the screen, which is from one of my colleagues, who's one of the founders of Pact, and it's Beth Scurry. And she says, if you can't deploy services independently, then naturally you don't have microservices. And not alone that, you have something that's actually very bad. You have a distributed monolith, which takes away all of the promises of componentization and leaves you with not much reward and a lot of effort behind the scenes. Okay, so what can we do to maybe improve this? So what I'm going to introduce to you briefly over the next 10 minutes is bidirectional contract testing. And this is an approach to allow you to be able to evolve either of those kind of sides of an integration on their own and fully understand if you're going to have any impact on any of the consumers in any of those upstream environments. Now, bidirectional contract testing is slightly different than consumer-driven contract testing. So I know a few people were here put their hands up to say they were familiar with Pact. Pact started off as being consumer-driven contract testing orientated. This is a little bit different. So bidirectional contract testing is a static form of contract testing where there's two contracts. One represents the concerns of the provider, one represents the concerns or the expectations of the consumer, and they're validated to ensure that they're compatible with each other. So it is schema-based rather than specification by example, which is more the consumer-driven side of the house. And it's very well suited to workflows that are, say, where you want to retrofit existing software with more robust contract testing, because you can bring your own investments that you've already made into your technical landscape. So you can use artifacts like OpenAPI if you're exposing RESTful services. You can bring those artifacts. You can capture contracts using your mocking tools of choice. Be that WireMock or Mountebank, etc. You can do contract verification using different tools, so you're not really vendor locked in, is what I'm saying. You have a good broad set of tools that you can bring with you. And I like to kind of think about it as being a little bit more of an inclusive means of contract testing. So consumer-driven contract testing really happens at the unit testing level, so you need access to the code. This involves a broader group of stakeholders, so it could be API designers or system designers, it could be QA folks, SDETs, and of course developers as well. So in this world, we talk about things that are called packs. And packs in terms of contract testing it's an artifact that just acts as a verifiable contract between a provider and a consumer. So if you think about an open API description, that is my promise to the whole world for the full surface area of my interface. This is what this API will do, but I can only assume that every consumer consumes the 100% scope of that contract if I want to evolve it, where this gives me snapshots into exactly the contract that I have as a provider with each of the consumers that is interacting with me. And this is like a trimmed down version of the previous diagram. So it's all about focusing testing on a specific integration point at any one point in time. So I don't care anymore about downstream or upstream components. I focus on where the change is, and I focus on the provider and the consumer of that particular change point. 5 minutes. Thank you. Now, there's lots of kind of statements out there by people who work quite heavily in the testing space. Joe Wallens is a pretty well-known tester who specializes a lot in test doubles and test mocking, and he always has this saying, which is, don't mock what you don't own. And I think the challenge with any kind of mock testing, of course, is that drift can creep in quite quickly into your assumptions. So you mock out your assumptions of what an interface is on, let's say, today, but will that be the same? Will it be valid 2 weeks' time, a month's time, a year's time? Now, what's different about this is that the interactions are always replayed against the consumer and against the provider. So you get feedback immediately if that drift has come in and if you've made poor assumptions. Now, it captures the interactions between the software components and it serializes them into a pact. There's a public specification for Pact. It's on v4 now, and it looks a little bit like this. Sorry if people can't read it, but it codifies basically that agreement between the two parties. So it tells you who the consumer is, tells you who the provider is, it tells you the interaction expectations between them, and then it has some metadata about actually, what version of Pact was used to create this Pact contract. So how does it work? So from the bidirectional perspective, as I said, you bring artifacts that you already have made investments into your let's say, development lifecycle. So in this instance, I have a provider. The provider produces an open API description for one of their RESTful or REST-ish endpoints. And they also provide, with a tool of their choice, they provide proof that they have exercised tests against those endpoints to prove that they conform to what they have codified into their open API description. So once they have those two things, they can issue those to the broker, which there's an open source broker, and then we also have an enterprise broker. So you provide those two things, which will establish a contract on the broker for you as a provider, and then consumers can interact with the broker to verify if their software will work with the latest published version of your provider contract. So you don't need to be available for consumers to validate if they're still compatible, and likewise, consumers don't need to be available for providers to validate if they are compatible with all of the consumers. So you have your open API, you have your test proof, using your own testing tool of choice, that this is all good. You publish them to the broker. And then on the client side of the integration, you obviously will have your own unit testing or mocking tools that you use. You can, of course, use the Pact DSL, but you're not mandated to do so. There's plenty of adapters out there with common unit testing frameworks that will allow you to serialize those unit test expectations into a Pact file. So once you have those tests there, then you will convert those or serialize those into a Pact file, and again, you will provide those to the broker. And then this is a little bit where the magic happens. So the broker then, or Pact in general, exposes this can I deploy CLI or API, depending on how you want to interact with it. So this can I deploy feature will be what tells you, is it safe for me to move the software that I want to move to the upstream environment? And it gives you that feedback directly on your own machine or as part of your CI/CD pipelines, or both, preferably. So what's queried as part of that can I deploy check is the matrix of information, is what we call it. So this is all versions of the API provider. It's all versions of the API consumer, the integrations that exist or the expectations that exist between all of those different versions and on all environments that are part of your ecosystem or your topology for this particular service. And it will give you that feedback instantaneously as to whether or not it's safe for me to deploy this change without breaking expectations. Now, I'll very quickly run through, this is a static demo, so don't worry about it, it's only going to take a second to run through. So just to give you a little bit of a feeling as to how this actually works from a developer perspective. So let's assume I have a provider API. So just in this example, it's written in C#, and I'm bringing an independent testing tool, Schema Thesis, to test the API. And then on the consumer side, we have some consuming client that consumes that endpoint, and I'm then, via my unit tests, I'm going to serialize those expectations into Pact, and then a simple CI flow in GitHub Actions is going to verify the process for me. So very, very simple products endpoint, or sorry, products API with 3 endpoints for get products, get product details, and then deleting a product. So I've created the code for that. I've then run tests using Schema Thesis to prove that I have implemented everything I've promised to implement in that API design. And then I have my provider CI. So a very simple GitHub action that grabs the code, compiles it, asks the question against the broker, hey, can I deploy this thing? And then if all is good, it will deploy. Now, because this is the first time through the process, naturally nothing will fail because I don't have any consumers yet. So up on the top left, this is a view from the broker. So the broker is giving me 3 question marks for a consumer because we don't have anyone yet. And then it's telling me about the provider contract. So it tells me about the version of software, the environment it's deployed to, when it was deployed, etc. And then I can drill in to get a view from a Swagger UI or OpenAPI perspective as to what is that provider contract. On the consumer side then, I crafted my unit tests using XUnit and using WireMock from a mocking capability. WireMock comes with an open source adapter for Pact, so it'll serialize those expectations for you into a Pact file. So what gets serialized here is just some of the endpoints that I'm consuming and some of the properties within the endpoints that I'm also consuming. And then I also have a different CI for the consumer. I know it looks very similar. Sorry, it's a very simplistic demo. So again, getting the code, deploying the code, asking the question, can I deploy? In this instance, it is checking against that provider contract to see, am I a safe subset of that provider contract? And then it's saying, yes, I can deploy. Thank you. And then I deploy. And then we can see we have a pact between a consumer and a provider, the environment, and it also serializes the expectations that the consumer has. So I get an insight into what parts of my API this consumer is potentially consuming. So let's run through a potentially breaking change. So if I was dogmatic from an API versioning perspective and I want to remove an endpoint, so the product owner has said, hey, I didn't actually mean for you to expose the delete product endpoint in that API. That only should be for our inventory management system and not on the public API. We shouldn't give consumers the ability to delete products from our catalog. I'm like, whoops, sorry, that slipped through. But again, if I was dogmatic from a versioning perspective, that would mean, hey, I better roll up to V2 here because removing an endpoint is a breaking change. But because I have the insight from a contract testing perspective, I can actually determine what parts of the API are being consumed. So I can propose this change. This is from a CI perspective, from example purposes, but even at the point of design, I can query the broker to say, if I was to make this design change to my API without even writing code, am I going to break any consumer? So I can go all the way to the design phase of the API lifecycle. So because, if you remember in the previous slide, the client wasn't consuming the delete endpoint, I'm actually able to safely make that change. So I don't need to bump the version of the API, can still keep it on the same code base, and I know categorically I'm not going to break any consumer. So that's pretty much a whirlwind example. I won't go through these because we're short on time, but it just basically introduces a completely rebalanced approach to the testing pyramid when it comes to thinking about APIs and how you test them for compatibility. And it's cheaper, it's faster, it's more reliable for integration-based testing, and it actually reduces the heavy bloatedness of end-to-end testing when it comes to microservices because they're not really applicable. There's loads of other benefits from an API management perspective and that I won't get into, but there's management and governance benefits too. I'll leave you with that. If anyone wants to learn more, just go to pactflow.io. There's a Pact University. I'm actually wearing a Pact Nirvana t-shirt here, which is like the utopia for implementing contract testing. But there's loads of coursework there that you can follow through in a whole range of programming languages. So have some fun with it, test it out. That's it. Thanks, everyone. Happy to take some questions if anyone wants some.
Yeah. So what exactly do I get? What's the information of the pact I get from the user side and the consumer side? Is it an example or is it?
It depends what you want to get from it. So as a consumer perspective, you will get back, if you check to see if your client is still compatible with the provider, you will get back exact information as to where you are no longer compatible with the provider. So
Does this by it register my example variables beforehand?
Yes.
Send them to the new API?
It will. So it's all kind of managed at the broker level. So the broker will store your packs as a consumer, and it will also know the version of the provider that you're depending upon. And it will make sure that in bidirectional contract testing, will make sure that you are a valid subset of what the provider offers in their endpoint. So I have a breaking example here as well that I can show you afterwards, and that'll give you some insight as to what you get back. But you will get back information on if you're not compatible with an endpoint, if you're not compatible with a property, let's say if it's an enum and someone introduced or removed an enum value that was there, you will get back information. There's a whole load of matchers as well, so you can kind of define your own matchers as to what's important for you and what's not important for you. You could have it as a simple regex check, but if you wanted to be a little bit more deterministic about that, you could be as well.
But those range kind of dependencies, I assume the ID is unique. I assume the order is by date, something like this. This would still break stuff if I randomly change it.
It depends if you want to go down to that level. So if you want to go down to the level of, product 10 must always be there, then you have to serialize that as an example that must always be honored. On the consumer-driven side, so if you really want to kind of drive that, you would probably use consumer-driven, and you can make a request to the provider that they will be able to manage that provider state for you as a consumer. That's more on the consumer-driven side rather than the bidirectional side. It's just a slightly different flow, and it's more powerful. It's more granular as to what you can do. Bidirectional is a little bit more coarse-grained, and it's working with the OpenAPI specification as being the maximum that the provider can offer, and then it's making sure that every single consumer is a subset of the latest provider contract.
Questions? Can you say something about the expressiveness of this, the types of tests that you can specify in this contract, the richness of the contract language itself? I have similar questions like Sebastian here, so I can do testing for the existence of an API or not, but I think there's lots of temporal properties that you would like to validate as well. Like deleting the same object twice should fail, for example. Creating the same object twice should fail. So can I express properties like that?
Yeah, you can create your unit test like that, and then if you do so, that will get serialized into the Pact contract. So if you're using the Pact DSL, you can kind of have when-then type of scenario-based construction, and then that will get serialized. So you can say, if we make one call and delete a product, then if we make a second call and try to delete the same product, then the the provider should return back a 404 HTTP status code, for example.
It's also possible to specify more performance type of requirements. Like, for example, I should get a response within so much milliseconds.
Yeah.
It's also possible to do, of course. Are these in the documentation of the Pact standard, or these types of?
It's covered between the Pact University, let's say, material that's there, as well as the Pact specification documentation. The vast majority of that should be covered. We're always trying to improve the documentation that exists for it, but all the documentation is open source as well. So if anyone finds any issues that's there, we're more than happy to accept some contributions. We're also putting together kind of a whole suite of actual hands-on courses for people to be able to follow along, and there's some quite some good examples. The name of the tool has momentarily left my brain, but where you have let's say the scenarios that you want to run through on the left. It's Killer Coda, sorry, that's the name of it. So you can kind of have, we want to run through this workshop or this use case example, so it has all of the kind of getting started guides and what you need to do on the left, but on the right hand side you have like the terminal and the IDE, and it's bringing it to life for you as you're stepping through, so it's very interactive from a learning perspective.
Yeah, small question, about the contract,
Mm-hmm.
the test in the middle.
Yeah.
Who is responsible for what? I mean, test in the middle, who will be responsible for fitness, or I don't know what? I mean, is there third party or only two parties in the contract?
Yeah, so the thing about this is the provider for any given API, the provider might have, like, let's say I had an API, and you're all different teams within my organization. I would have a bespoke pact with each of you, and if you're making any changes for that moment in time, when either you're testing or I'm testing, if I'm still compatible with you, it's explicitly between us. But that's not to say that there's not a whole other wave of consumers that are also consumers with the same provider contract managed in the broker. And the benefit about that is, from a provider perspective, I could be making a change and I can determine if it's going to impact any one of your pieces of software. I don't have to explicitly go to you. And it's not that it's going to be magic and solve all problems. Like, there will be, the benefit is, at some point in time, I will be making a change. And of course, I showed you the happy path there, and I didn't have time to run through the non-happy path. But more often, the real value comes when I am making a change and it is going to impact one of you. At least then I know who it is, and we can determine, okay, like, from a provider team perspective, we really don't want to create another version of the API. We really want to make this change. It's you and another team who it's going to impact, but for the other 15 consumers that we have, they're all fine. How can we work together to get it? And there's generally what teams will do who've kind of got quite mature in the process is they'll use an expand and contract temporary scenario between them. So I might expand for a period of time to handle the breaking change that would impact you, and we will determine when that should expire. Then so it's a little bit like a feature flag, but we will kind of have that expand and contract pattern to make sure that we can deploy in a practical, sensible way without me just having to create another version of the API.
But the contract must be first time right, I suppose, because if you are forgetting something to put it in the contract, and someone, and you have to sort of highlight this and change the contract, you're sort of forced now to upgrade the API. So otherwise, you've lost the ability to track the traceability downstream, right?
Yeah, in the bidirectional sense, it's kind of first time right from a provider perspective. So it's saying, hey, you're already using a design first approach potentially for your API delivery. So you invest in crafting that open API description, and therefore we will take that as your proclamation or your promise. But you also have to give us some proof that you've tested this thing. Now, there's ways that you can overwrite that if you really want to, but the rule, or like the golden path, is that you have your provider contract, you're providing proof to the broker that you have exercise tests against the surface area of it, and then that becomes your provider contract. On the
the value of that is as good as the level of testing that you did as part of the proof that you provided.
correct, yeah, yeah. If you skip that, yeah, you still will have. And it's the same on the consumer side. You know, your consumer contract is only as good as the unit test that you've created, and if you haven't unit tested 80% of your software, then your pact is only as good as that.
Well, thank you. That's all the
Thanks,
time
everyone.
we have.